Hello, my name is Salini Lona, and this is the course project for the Machine Learning Foundations for Product Managers course by Duke University. For this project, we will be building a model to predict the electric energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. We were provided with a data set that contains 9,568 hourly average ambient environmental readings from sensors at the plant. So this is the data set provided, and this is what we're going to be using for our modeling. My modeling task is a prediction. My data type is structured continuous data. And the features to use here are temperature, ambient pressure, relative humidity, and exhaust vacuum. The energy output, this is my target, and this is what I'm trying to predict with my model. The first thing that I did for this project was to split my data. So I created my test data, which contains 1,500 data points, about 16% of the total data points. This test data was only used for testing. It was not part of the validation or training data. Next, I used my training data to create my validation sets. For validation, I am using cross validation. I split my training data into three k-folds of the same size. And I am using each iteration to test one of my models. My algorithm is a regression for all three models. I have different combinations of attributes because I want to make sure that all of the variables are actually impacting power outputs. For the model evaluation, I am looking at the total error encountered with each model. I'm also looking at the p-value, whether my attributes are statistically significant, and the R square to see how well my attributes correlate with my targets. For my first validation set, I am using only three variables. I removed the ambient pressure from the equation and I'm testing how well my model will perform with only those three variables: temperature, exhaust vacuum, and relative humidity. When I look at my R squared, it is 0.9279. My standard error is 4.586. When I look at my variables and the p-values, all of them are statistically significant since the p-value is less than 0.05. My next validation set uses only one variable, which is the temperature. And when you look at the R square, it's 0.8994. It's not as good as the first model. And my standard error is 5.43. So my standard error went up a little bit. So this model is not performing as well as the first model. When I look at the p-values again, p-value of 0, which is probably an approximation, it's probably pretty close to 0, which is statistically significant. My last validation set includes all the four variables provided. And when I look at my R square, it's 0.923, and my error is only 4.665. So my error decreased slightly. When I look at the p-values, all of them are statistically significant. It looks like all of my variables are actually influencing power output at the plant. For this reason, I will be using this algorithm, which includes all four attributes, to train my data and to test my model. When I look at my training data, my R square is 0.928. My standard error is 4.58, which is basically what I had when I looked at my validation set number 3. So now using this model to test with my test data, I calculated all the predicted values using the 3 variables from validation set 3. I use those coefficients over here. I have the intercept and the coefficients for each of my attributes. I use this in my equation to calculate the predicted energy output. Since I have the actual output provided in the original data, I calculated my residuals from it. I also used my residuals to calculate the residual square sum and the SSE, which is my error. The error here is 4.458, slightly lower than what we saw in the validation set number 3 and the training data as well. So it looks like my model is performing really well. And this is what I will be using to predict our output. Thank you very much.